Good afternoon, everybody. My name is Todd Probert. I'm the President of National Security and Innovative Solutions for CACI. At CACI, we focus on delivering world-class technology across all C4ISR domains. We are experts in EW, cybersecurity, as well as operations and resiliency in space. So you might wonder how we do that. Software is one of our superpowers. We have decades of mission software development expertise, enhancing and securing critical systems that advance speed to decision-making and situational awareness. Also, we have a broad portfolio that features investments made ahead of need for systems that provide resilient RF and communication solutions. For example, we have expertise in photonics, AI-enabled signals intelligence, and electronic warfare. Our counter-UAS portfolio offers modular solutions. And with the largest threat signals library in the world, our systems can detect, track, and defeat those threats with advanced, decisive precision. Today's panel is titled Readiness, Capability, and Capacity: How Industry is Helping the Navy Advance Future EW Threats. We are going to discuss current and future solutions to specifically help the Navy's challenges in EW, SIGINT, and the cyber arenas. This group of experts will discuss how emerging technologies and novel design approaches will ensure strategic overmatch in the highly contested EW environment. As we all know, the dynamic, ever-expanding nature of the EW threat requires future-proof solutions. Scalable network and distributed capabilities are needed to meet capacity challenges. The readiness of tomorrow's EW, SIGINT, and cyber capabilities will require AI, ML-based innovations. And frankly, to achieve all of this, industry and government must adopt truly open architectures that are purposely designed. So why don't we get into this discussion? I'm going to have each of the panelists introduce themselves. We'll get into the questions. So Nate, how about you start for us?
Absolutely. Hey, how's it going? My name is Nate Dibbling. I'm a program manager with CACI. I manage the Navy portfolio. Primarily customer is PMW 120. Inside of my portfolio is work that we do for D6N, RTSO, Classic Reach, and distributed operations.
Thanks, Nate. Dan?
Dan Wetzel from Sierra Nevada Corporation. I've been with Sierra Nevada for about 19 years, really a signal processing specialist. So big digital signal processing, FPGAs, CPUs, GPUs, those sorts of things, advanced algorithms. Sorry, scoot up a little more, thank you. I've worked for the last 7 years on a program called MISD, Multi-Sensor Development, that really is mostly a NAVAIR program. That's how we relate to the Navy, and we're partnering with CACI on the Spectral Pursuit, so that also brings some relevance to today's discussion.
Thanks, Dan. Christian?
Yeah, hi, good afternoon. Christian Boberg, Dell Federal. I'm an enterprise architect. I've been in the IT industry for over 25 years. Some of my primary accounts supporting the Navy goes way back to NMCI, NGEN, and SMIT. I'm currently working on SharkCage and Spectral. And my primary focus is storage and server.
Excellent, thanks. And finally, Josh.
Josh Peterson. I started serving as a CT in the Navy, kind of dating myself going way back. I've spent 22 years working with BAE Systems. I'm now a tech director for the C4SR division. Dating myself again, my Navy time was spent a lot with Combat DF and Code Blue systems, but then I went on and did IED defeat, crew development, technique development for Compass Call, interesting work with DARPA on cognitive EW systems, now supporting this program.
Good. Hey, thanks, Josh. Hey, guys, why don't we maybe get a little bit closer to the mics? I'm getting the high sign from the back in terms of hearing it. But let's jump right into the questions. So our panel questions today are aligned with the CNO's navigation plan, and specifically the force design imperatives necessary to build our future capabilities: distance, deception, defense, distribution, delivery, and decision advantage. Let's examine how industry is delivering technologies today that are already aligned with these imperatives. And let's look at where industry is investing to enable these future warfighting capabilities as they relate to EW, SIGINT, and cyber. So for question number 1, an excerpt from that CNO's plan, expanding distance reads, long-range precision fires across all domains and platforms with greater reach will enable naval forces to strike hostile targets while increasing our own survivability. Nate, so the first question I'm going to hand over to you. What technologies are we seeing today or just over the horizon with respect to EW and SIGINT that are helping expand the distance?
Sure, thanks, Todd. So one of the things, there's lots of avenues the Navy can take to expand its distance. But one of the things I think that are really close and something that they can get to soon is leveraging all of the systems, the different EW/ISR systems that are out there between the DoD and the IC and even some of our foreign partners. The Navy has done a really great job of building their systems. Everybody's kind of built a really good job of building their different EW/ISR system that does a different thing or similar things really well. What we can do is bring all of those things together to expand the network and the distance in which the Navy can sense, detect, fix those things that are out there that we're looking for, and really broaden that without a significant amount of technical investment in terms of hardware or new systems, just by bringing all the things that are out there together. We do this today with some of the work that we're doing for the Navy and then also for the NSA. In particular, our Classic Reach program allows us to do distributed SIGINT operations where we reach out and touch a wide range of the distributed systems and then remote those things back to a central location so that different operators can touch those. Expanding on that, our NSA solution that we have helps with joint interoperability, right? And so it's a system called Common Services. It's an evolution of joint interoperability. And what that allows us to do is it allows us to connect a very large number of things together and build mission sets with all of those different components that are not just Navy, not just DoD, but are IC and also international with those partners that we trust in order to come into that. We do that in a couple of different ways, but there's really 4 imperatives to do that, right? First, we've got to get all of the systems together and communicate that, hey, there's something on the network. 2, we need to say, this is what I can do. 3, we say, this is when I'm available to do it. And then the 4th is one of the most important, is that we get everything talking in the same language, using the same set of instructions or messages that then allow us to do joint mission command and control over all of the things in the system. And then what that will do is it'll drastically expand the number of systems, sensors, processors, different components that are going to be needed in order to identify targets, especially when we start looking at our near-peer and current pacing threats.
Yeah, I like that. Sort of make sense, act through an architecture that expands the web of sensors and effectors to affect that, expand the distance. I like that. Dan, you want to chime in?
Yeah, sure. So as a SIGINT sensor guy, when I think of distance, I really am thinking more of physical distance. And so the technologies that have really come along in the last 8 to 10 years, and here I'm thinking specifically about improvements in analog to digital converter technologies, digital to analog converter technologies. A lot of these are driven by advancements in 5G cellular and things like that. It really wasn't the defense industrial base that drove those changes, but now we have these ultra wide bandwidth A2Ds, and then the ultra fast FPGAs and GPU processing to crunch all that data. So I guess that's really when I think of distance, I'm thinking more, sensor performance, improved sensor sensitivity means we can detect signals with our SIGINT sensor at much greater ranges, improve our standoff distance and things like that.
No, that's great. I think there's a speed component to that and an enhanced capability, which ties into the web and certainly hits the distance.
Absolutely.
Gentlemen at the end, anybody want to chime in? Or?
Yeah, I think from an OEM perspective, the industry is delivering smaller, more ruggedized edge devices. We have partners like Tracewell that are hardening our highest performing processors down to shipboard size, weight, and power, and mil spec. So I think, and they're delivering COTS. These are COTS solutions. So reducing cost and complexity and size, weight, and power, I think, are key to enabling all these virtualized sensors to be able to run ML and GPU-type performance-oriented applications.
Yeah, no, I like that as well, and it's exciting to have you up here, and you know, industry is embracing commercial technology in new and different ways, and certainly the faster we can get it into our architectures, I think the better off we all are. So it's definitely opening doors and enabling it. Nate's looking to jump in here and close us out, so let's go to Nate for the last word on this question.
Yeah, so the one thing I would say that's really important with what you two added into it is that whatever we go to for an architecture and however we build this interconnectivity of all these different things, it has to be built in a way that is future-proofed, right? So we have to be able to retain the legacy systems while also adding on these new capabilities, right? And that is something that we've been doing with the common services piece, with the way that we've formulated the solution and the message set that goes along with it. It adapts to new ideas and allows you to bring innovative solutions to the system while also maintaining all of the existing infrastructure and all the existing mission sets. So you just are simply adding new capability to it rather than going back to the box and recreating everything because you made one small change. And I think that's a really important thing that we have to keep in mind as we go forward. Otherwise, we're going to constantly just keep rebuilding the same thing over and over again and investing our money in things that we've already done.
I agree. It has to be software-based going forward. And as an FPGA guy, I would throw in firmware-based as well. But yeah, the future is software and firmware.
I like it. We're off to a great start,
Yeah.
expanding the distance and going the distance on question one. So let's move on to question two. Question two is about deception. So again, another citation for the CNO plan regarding leveraging deception reads, stealth, concealment, maneuver, mission control, and electronic warfare that degrade enemy surveillance and increase adversary uncertainty, enabling naval forces to operate effectively in contested battle spaces. So Dan, I'm going to give this one to you, keeping the fact in mind this is obviously unclassified.
Sure.
How is industry helping with EW and SIGINT technologies to support deception?
Right, so here, again, immediately as a sensor guy, I go to electronic deception in particular. And so as a SIGINT sensor guy, or if you've been around SIGINT sensors, you might be asking yourself, like, well, what does SIGINT have to do with, you know, active deception like you'd see in an EW kind of product? Well, I say good EW starts with good SIGINT because there's actually a big loop that goes on here that probably a lot of people in the audience are aware of, that there are, you know, national level and dedicated platforms that go do SIGINT, in addition to other, you know, SIGINT capabilities that are on lots of ships. But collecting that those signals that feeds back, you know, at a national level to know how to program the jammers, because the time scales that are going on here are so different. You know, the jammers or active deception, electronic deception kind of capabilities need to react in nanoseconds to microseconds, those kinds of time scales. Well, you know, where do these waveforms come from that they're reacting with so quickly and producing this deception? Well, that all comes from SIGINT. So having good SIGINT, you know, is foundational to having a good, you know, electronic deception capability.
Great, no, good. Hey, Josh, anything from BAE to add on this one?
Sure. Yeah. So it's interesting when you kind of talk about deception and understanding how it really works. So one of the things that your SIGINT system can do that we've been working on a program with IARPA called Scissors is, and it was interesting as I walked around the expo here, I saw a whole bunch of spectrum awareness kind of gear, trying to actually understand what's out there, right? What's out there today? Can you see changes, anomalous behaviors? But can you go deeper with AI/ML and just understand if there's snugglers or signals out there that are mimicking other signals, right? So there's all that work that's going on out there, and it takes these kind of systems to actually run it and then make sure it stays deployed with the right software and background tools.
Fair enough. Any adds? Dan?
Yeah, I'll
Or
just
Nate?
add in, there's I think there's another component to deception besides just actively trying to create the deception. It's also, to do this well, you got to know yourself as much as you know the enemy and the enemy signals, right? So you have to be able to understand what your electromagnetics output is, right? Otherwise, you're not going to be able to effectively create a good deception, right? And the Navy's very aware of that. They're working very hard on RTSO, which is one of the things that we're working on, to bring in that real-time spectrum operations, plan out what my MCOM is going to be, and then monitor my performance against that. And once we get really good at that, what we'll be able to do is know what the enemy capabilities are, know when and where we're going to be detected, and then create a deception to offset the potential of being detected in that space. So I think RTSO is a big piece of that, and being able to sense what's going on. And I think we bring a lot to the table for that, specifically with our Spectrum Guard and our MB type capabilities.
No, absolutely. And I think this whole area of deception and just EW as well, it's sort of a back to the future type of construct. And we're seeing a lot of activity from a blue radiation standpoint and making sure we understand how we're projecting, from our forces, to your point, Nate. And then obviously the EW has been a tell for where the enemy's going since the dawn of RF and radio activity. So it all ties together very well. Okay, so let's move on. So for the next one, I'm going to talk about hardening defenses. For the purposes of this discussion, this means integrating directed energy with hard kill and soft kill defensive systems to disrupt attacks and keep naval forces survivable when targeted by adversaries. Christian, how do you see the EW and SIGINT systems of tomorrow supporting this hardening defense concept?
Well, again, from the OEM perspective, hardening of servers and the network takes me to zero trust. Everybody's heard about zero trust, hardening of systems, the 5 pillars of zero trust from the end user device to data to the network to the application. So Dell has been doing a lot of work with the DoD and US Cybercom on a program called Dreamport. Dreamport's located in Columbia, Maryland, and what it is an incubation lab where over 40 cyber applications are being tested to meet the mission for the DoD's reference architecture for zero trust. And Dell is providing a trusted infrastructure to run all these cyber platforms on, so customers across the DoD and industry, I suppose, could come in and test their environments. Most customers have some aspects of zero trust protection already in place, but to get that zero trust certification or ATO, you have to cover the entire spectrum, and programs like Spectral need to be protected from the network. You can't have intruders getting inside your network and positioning malware or some sort of other destructive virus. So yeah, Dell's doing a lot of work. We're also opening up our own center of excellence in Round Rock at corporate to do the same thing for our commercial partners and customers.
Yeah, so that's good, and that ties back to the first question in terms of how, we're seeing the DoD leverage commercial applications, and in fact, Dell is clearly, and other commercial companies are leading the zero trust push, and we're finding great ways to move into it. Hey guys, maybe let's take it back though. The citation from the CNO's plan talks about integrating directed energy with hard kill and soft kill defensive systems, which probably gets to architecture and system of systems as well. So Nate, maybe do you have any thoughts on bringing it back to that?
Yeah, so getting back to where we were at in the beginning is when you have all of these EW ISR sensors out there, and now you can detect the thing, right? The next obvious step is to get to where you can get the kill, right? To get all the way through the kill chain, right? And so by taking all of these existing systems and putting them together, what you can do is you can build a mission set that is a higher level activity that goes from the detection all the way to the decision to take some action with an electronic warfare attack, and whichever ones that are out there. And I don't want to talk about them specifically because that gets into a space I can't talk about here. But the important part here is automating that pipeline and that tool chain. What we've seen time and time again, every time I talk to a Navy operator, is the way that they get information from this system to that system is a Post-it note. The Post-it note is our interoperability system right now. They say, here's the thing, right? And then they run it over to the next thing, and then that gets run over to the next thing, and then eventually it makes it to the person who can make a decision, right? And so that's not a good enough solution for our sailors. They don't need to spend their time writing things down and forgetting, all of that piece as they run between compartments in the ship. It needs to be automated. The systems need to go from the detection all the way to the point where somebody's pushing a button, and that button is then taking the activity that you're talking about.
Yeah, and I think it takes it back to that sense, make sense, and act, and the underpinnings of that being an open architecture that allows you to tie all the various aspects of it together, as we were talking about on complex systems for question number 1. So I think that's well said. Anybody want to tackle the hardening question, or I'll move on to question 4? Okay. So the next point is increasing distribution, and the CNO says distributing forces geographically and in all domains enables them to threaten an adversary from multiple attack accesses. Smaller, lethal, and less costly platforms, including manned, unmanned, and optionally manned, further complicate threat targeting, generate confusion, and impose dilemmas for adversaries. So Dan, I'm going to field this over to you.
Sure.
How is industry partnering with the Navy to address increasing distribution?
Sure. The important thing to understand is that this emerging generation of low-cost unmanned platforms, their EW payloads are being enabled by these tremendous improvements in silicon technology that I talked about earlier, but here there's even a more important one, which is the development of essentially AI processing infrastructure. So there's a lot of different AI kinds of processors out there. They're generally meant for inference, and essentially it's a very high throughput, high bandwidth math engine that you get in these processors that really enables these EW payloads that are being deployed on the small unmanned platforms to undertake this really tremendous amount of activity that they have to do to make a decision, because these unmanned platforms, you can't have them essentially sending raw sensor data back, over military networks, just because of the congestion alone. It's too much. They have to be smart enough on their own to be able to make decisions related to EW, or at least generate reports. Really condense that data down to a level where the network traffic is tolerable. And so I see that as really, again, one of the key technologies and advancements that's enabling this distribution and proliferation of the small unmanned platforms.
Yeah, and it keeps coming back to, I'm going to say orchestration to sum up kind of what you said, and across that, and when we're talking distributed platforms, when we're talking, non-homogeneous platforms and working across it, it's orchestration. And it comes back to, and I think every one of these questions sort of circle back to how we're leveraging the architecture in a different way, and how we're driving kind of that software orchestration of systems to do what we need to do in the CW fight. And it's sort of by happenstance, but this team that we've assembled here, it really comes down to that. Each of you have key points to play on the physical hardware side, but then orchestrating inside that open architecture and building the enablers that allow us to do that systems of systems things. I don't know if you're giving me a signal over there, Christian, but if you want to jump in, let's do it.
Yeah, well, you're talking about orchestration, and we're talking about Kubernetes and microservices,
Absolutely.
right? So infrastructure as code, zero-touch deployment. So you can take your EW applications and deploy them and take the errors out of it. It's been pre-tested, pre-certified, and you can just run the code, and running the code on bare metal studies have shown it's 30% more efficient and faster than running it on top of a virtualization stack. So you're getting a faster, more efficient, less error-prone delivery of applications to the unmanned or to the onboard shipboard environment.
Yeah, well said. Josh, it looks like you're looking to jump in here
Yeah,
too. You got
kitchen.
to be more aggressive. These
No,
guys
I'll work on it.
hogging all the time.
Yeah, so it just feeds right off the same thing that you were just talking about. But when we look at the capabilities we're putting out there, they really have to be developed with scalability in mind. So when we start with a capability that does soup to nuts, whatever that interesting probably classified capability is, right? It can't be designed for the biggest system that you want, right? You may want to think about designing it for that small UUV and then scaling up from there. So even if you can run it on that giant thing, right? If you can take it, scale it down, running on something small, orchestrate across all of your network of sensors, that's when things really start to gain traction.
Yeah, I like that. And I'm gonna pull an audible here. And anybody want to jump in on digital twins? Because I think all the companies up here are doing some fantastic work, kind of modeling inside the computer and doing those what ifs or preparing for that orchestration or however you want to frame it. But anybody want to jump in on digital twins up here?
Sure, I'll start. So the Navy actually is doing a pretty good job of thinking about that and building that out with the Overmatch Software Armory and their Canes digital twin that allows you to go out and install your Canes baseline software into their environment and test it and go through some of those operations that you want to do to make sure that when you deploy it for real or when you get to the test, it's a lot less, right? And I think the digital twin idea needs to be more and more what we do, because the amount of time and effort that we put into physical testing and representative hardware, it's too much. There's a lot of wasted time in there, getting the software installed, testing it out. We can do 99% of it in the cloud or in a digital twin, and then the last mile, maybe you install it and do a few tests. But like AI SIT, for example, takes months and months and months to prepare for, months and months to get everything through, and then finally you get the approval to go put it on a ship. But that's not going to be fast enough in the next fight. The next fight, we're going to have to get solutions to the warfighter faster. The ships are going to be underway. We're going to have to update them as they go. Digital twins and that test environment are going to have to be the way that we get that done, because we just don't have the time to wait for all of these very lengthy processes to take place.
Well said. Well said. Go ahead, Dan.
Well, when it comes to digital twins, I'm an only child. Sorry.
Okay. I'm trying to figure out where to go with that. But
I'd have to defer to my money Matt in
noted.
the audience. Yeah.
okay, well, so I'll move on. And there's a lot of ground to cover here, and this is sort of the, particularly when we're looking at high tech and software and in the EW suites that are out there, this might be more on the pedestrian side. But what solutions are y'all seeing from the standpoint of ensuring delivery? And the CNO helps us again here. Ensuring delivery covers resilient logistics, connecting the foundry to the fleet, enabled by secure communications and information technology. Refuel, rearm, resupply, repair, and revive distributed naval forces down to the last mile. And we can certainly cover wherever you all want to go on this, but as it relates to the architectural stuff that we've been talking about, the decision, the decision aids, the speed of software and all of that, why don't we try to focus on that? But this, in my mind, is one of the biggest failings of putting software to effectively work for you, is that ensuring delivery component to it. So Nate, let's start with you.
Yeah, so, our near peers are going to put up a challenge when we get out there, right? They're going to do things to us that are going to exploit weaknesses in our systems. That's just going to happen. We have to be able to get software updates, fixes, new technology out to the fleet really fast. And if we don't, they're not going to survive the first contact with those electronic warfare forces on the enemy side, right? So to do that, we've really got to break down the way that things have been done in the past. The way that the software's been taken to the fleet is just not fast enough. And to be quite frank, it's just not good enough either. And the things that we have to do, the Navy's already thinking about some of it, and Christian alluded to part of that, is that with things like the Overmatch Software Armory, the Agile Core services that they're putting together, and their RAISE process, those things are really important to how we're going to move forward, right? But there's really three key things to moving forward and getting that delivery to the ship as fast as possible. One, and Christian alluded to it, is agnostic automated installation, right? If a human has to do anything where he pushes a button more than once, that can be scripted. There's absolutely no reason why a specified software engineer needs to go to a ship to install something, or why I need an installation script that's this big, right? Everybody who's been out there who's seen it, those installation scripts are just massive. They're very lengthy, they're very hard, they require you to go find lots of information. We can script all of that, and you can do it in a way that is environment agnostic. So it can install into a virtual environment, it can install into a container orchestrated environment, it can install into the cloud. Things like Terraform, we're using that today on DSIGs to install into the various different environments that they're going to have. They're going to have bare metal environments, they're going to have cloud environments, and they're going to have virtual environments. And we're using that to script that across and make one single place where all of that gets collected as infrastructure and configuration as code. You push a button, it installs. We did that for DSIGs just recently on one of our ship installs where we got a multi-month install down to about 30 minutes. And just by pushing a button, right? The second thing is a full CI/CD pipeline, right? The ability to go from the factory to the ship is absolutely necessary. That's how we're going to get this done, right? So that's going through all of the process, from the hardening to the cyber to the testing, and then getting it out to the ship, right? We can automate that whole thing. The technology exists. The problem is really in the policy. We need to revisit and really go down and break some of these things that have been long-standing traditions and long-standing beliefs and challenge them and say, look, we've got to make this go faster. How can we get secure software to the edge faster? And the CI/CD pipeline thing, there's lots of examples of it. It's all out there. It works. Industry and the commercial world is doing this every day. We can do it too. We can get that out to the ship. And a big part of that is also containerization. So containerization is going to make and that's the third point, and then I'll let the other guys talk. So containerization, what it does is it allows us to install all of this stuff in a resilient environment so that if some software piece breaks, it detects it, restarts that process without anybody having to go and do it. If you've ever run a tier 1, tier 2 help desk, you've gotten tons and tons and tons of calls where this process stopped, right? And then you have to go restart it, and you have to remote into the machine and all that stuff. Container orchestrators like Kubernetes just notice that thing stopped and restart it. The other thing it does is when we're delivering software updates over the air in terms of containers, we can be a little bit more risk acceptable, because what happens when you deliver the container, if it doesn't go well, just roll it back to the previous container. It's all contained on in the container repository, and you can just tell it to not load that next one, and it's fine. So there's a lot more flexibility and a lot more resilience in how it gets deployed. It'll solve a lot of the constant nagging logistical problems that we see in our help desks and things like that.
Nate, it sounds like you're in the middle of it, and I was going to re-vector, but Dan, why don't you jump on, and
I was
I'll...
just going to say quickly that the continuous integration, continuous delivery methodologies are the norm now. So CACI does it, SNC does, pretty much everybody does it. I'm sure BAE does too. The thing that surprised me about it is that you do, I was very skeptical embracing agile methods and this CI/CD stuff from the beginning. But really, in the end, not only do you get it out quicker, but you do, it also does improve quality and reliability of the code that you produce, in addition to getting out more quickly. So I just wanted to make that point real quick.
No, and so great coverage of it, and I think there's been fantastic gains in the last 5 to 10 years across really the entirety of the DoD. Maybe we're still struggling with tethered networks that are less complex than what the Navy has to deal with. So maybe can somebody tackle it's a distributed network. It's not tethered. It's degraded at times. Continuous ATO, when you have a tethered network, has its own challenges as you go work through that. version control, just the configuration management. Again, not the sexy part of it, but can somebody maybe have some thoughts on that? I'm going to point to you, Christian, because you guys are certainly thinking through CI/CD in a different way at Dell, and you've made great investments over the past couple of years with some fantastic companies that are thinking through that. But the Navy's got some particularly different challenges.
Yeah, I was going to go a different angle on secure supply chain with logistics, but I'll answer your question. I mean, the edge is presenting a new challenge for Dell as well because it's exploding. Smart cities, smart farms, smart edge in austere environments and network challenged environments. So Dell is coming out, and I don't have a lot of information on this, but it's called Project Frontier. It was announced in October of last year. It's supposed to be coming out mid-year this year, but it's an edge and IoT lifecycle manager, allow you to be able to push over-the-air updates to, I mean, the edge is, if you think about it, it's the opposite of the data center. Data centers have thousands of servers, and you have to manage and patch them and update them all the time. Now you have thousands of servers or hundreds of servers in hundreds of different locations on hundreds of different network connections, and some may be up, some may be down. So Dell is taking Project Frontier to be able to manage the edge through the life cycle, to get those updates out there and manage, who did I update, who didn't I update, who's got a challenged network, and kind of manage that challenge, because it's a real challenge to be able to manage 150 surface ships, half are in port, half are satellite connected, and half or a third are not connected at all. So how do I keep them all synchronized and updated?
Yeah, no, good point.
More info to come as it comes out.
Okay, so let's come back to the secure supply chain, but I got one more question, and I'm gonna field it out to the audience, and we'll come back to the secure supply chain one. But getting through all of the Ds in the CNO's plan, the last one specifically focused on generating decision advantage. And the CNO states, naval forces will outsense, outdecide, and outfight any adversary by accelerating our decision cycles with secure, survivable, and cyber-resilient networks, accurate data, and artificial intelligence. Connecting sensors, weapons, and decision makers across all domains enables naval forces to mass firepower and influence without massing forces. So Josh, I'm going to field this one over to you. There's a lot in there, but what technologies are you seeing your companies working on that will help generating decision advantage in the future?
So I look at this from kind of one particular vantage, I guess, is really how do you get the capabilities that we're developing in our early research and development programs, and how do we get those out and fielded as quickly as we can, right? So a lot of that has everything to do with everything we've been talking about so far. So the open architectures, the SDRs that we all work on. It's funny, as we were kind of talking through some of this, right? Like BAE has a CACI app running on one of its systems. I'm running one of my apps on S&C system, right? It's all over, and the government is pushing us exactly that way. So that's interesting, and we're working that from the perspective of a lot of existing capabilities, but how do we take those really new ones and get those through really quickly? And a lot of that has to do with the open architecture development. Every one of our services has a different one, right? So what leverage building blocks do you use at the right places in order to facilitate that? And a lot of that goes right back to containerization and architectures. And we see programs like DARPA Stitches actually trying to figure out how to talk between those architectures cleanly, and it's done that plenty of times. I think it's interesting that it's easy to talk about kind of the technology around this. It's hard sometimes to talk about the rest of the problem, right? So we have business model problems, right? How do people who have developed hardware and FPGA-based processes forever and ever, how do we move towards a more software-centric business model for ourselves? And that can be challenging for some of us and maybe not for others of us. Likewise, our customer hasn't necessarily transitioned as quickly to buying software capabilities and services versus going to buy a piece of hardware, right? It's easy to walk around this place and find tons of hardware, right? It's not as easy to say, oh, that's a software that'll run on all of this hardware that are available. So that's an interesting, different way to look at it. And then who's really responsible for saying that capability is the right one for this particular platform and this particular mission, right? How does that get orchestrated? Because a lot of us have the same types of capabilities that run on our own individual platforms and services and sensors. And how do we make sure that the right one ends up in the right place at the right time to actually execute the mission that we're being asked to do? So I think those are some interesting perspectives.
No, most definitely, and I wrote down a couple of things, and I think I want to foot stomp them because, you know, tomorrow's challenges are about industry and the government coming together to bring unique solutions forward, right? So you said a couple of things, I'm going to use different words, but agnostic approaches, collaboration, you know, inside of you know, competimates that are out there, and really industry leaning in, and I think that's a hallmark of something we've aspired to do at CACI. We're fielding in our DSIGS enterprise really a microservices-based architecture where we're in a humble position of sort of being the architectural custodian, but we've got the best capabilities out there from the likes of BAE, SNC, Dell, and in fact Lockheed and L3 and others that come into it. And in that microservices work, you know, if some algorithm comes along tomorrow that's bigger or better or faster or whatever, we've got the ability, because of the architectural approach and the fact that we haven't IP locked everything down to the nth degree, the ability to switch it out on the fly, those continuous ATO, you know, type of constructs, the version control and working through it, really gives us the speed of software to tackle things that we need to do, you know, going into tomorrow. So I'm gonna cut it there from focus questions. I can come back and certainly we can probably riff on just about anything here, but wanted to give you all the opportunity to ask questions of us, and we'll see where we take it. So we've got a taker here, please.
Alan Bowman here from the NC3 Enterprise Center. Sorry, Alan Bowman from the NC3 Enterprise Center. I'm curious from an industry standpoint, what kind of a demand signal you are getting from government and so forth for interoperability, but more to the point, how do we expedite services? Because to me, electronic warfare, or EW, equals INW, for indication and warnings. So when we're looking at larger mission essential functions, our mess between situation monitoring, decision making, the faster we can get those sensors when we talk in terms of EW. This is primarily Navy-centric in this environment, obviously, but looking at from industry, and you even mentioned, I believe, as far as the different services kind of approach things differently, you know, unique mission sets, obviously, but that's one of the things that I'm really concerned with is how do we, being government, what messaging do we need to do across through the joint staff and so forth to get everybody on board? Because when you have that DDG out or that SSN out doing their thing, decision making and situation monitoring, the speed at which we can get that information back to the decision makers is critical. And I'm just curious if you guys are getting that demand signal, because as JADC2 broadens out and gets more traction, so that we can talk between services and get those sensors and that sensor information to key decision makers instantaneously, not with processing and so forth. So are you seeing more unity in the communities across services? And if not, what would you say would be helpful from a joint service type perspective?
So I love the question, Alan, and it also has a little bit of jeopardy in it. So I'm reading it of, hey, give us a report card on how the government's doing to kind of go drive through all this. But I think it's a fantastic question. I think that this journey has been one that you know we've kind of slowly gotten out of just kind of waterfall development and milestone, you know, 10-year programs of software and moving into a new space. And I think there's a lot of great successes, but let's put it to the team. How's the government doing? Specifically, how's the Navy doing? And what can we impart to help Alan do his job?
So I'd like to describe in particular the MISD, the multi-end sensor development, and actually it's the one that Joshua works on with us at SNC. There actually are a few different companies that are able to quickly implement third-party apps and put them on the MISD sensor. That it's a little bit different than your normal, traditional open architecture in that, no committee really got together and said, here's all the messages we're going to send or whatever. It actually started with a strong personality in the government, insisting that the interfaces be government-owned, and that the software development kits and firmware development kits also be government-owned, and the change control boards for those SDKs and FDKs in order to be able to develop apps and deploy them on MISD are really controlled by the government. So you have this ecosystem of partners that are able to develop apps quickly and get them out. So I think MISD is a success story there. Again, that's mainly a NavAir thing. There's one NavC platform that we're on, but in general, I think that's a good, an example of one way to do it that's working well.
So B, but increasing to A very rapidly is Alan's great in that regard. All right, I like it. Anybody else?
Yeah, so I'll jump in real quick. So I would say it's mixed results, right? I think what's happened a lot is that the way that the acquisitions has been divided into silos to a certain extent, right? Like I've developed my thing, right? The main thing I get graded on is whether or not my thing does its job, right? My tertiary grade is whether or not it interoperates with other things, right? And so, for a long, long time, we've been really focused on making my thing do its job. And I think what I've seen here recently is a transition from that being a primary thing to the primary thing being that plus now interoperate with other systems that are my left and right within the acquisition community.
I'm curious because I know that JADC2 is a bright, shiny ball that everybody in government's going to go chase for a while. But I'm curious if some of the efforts that I'm part of as well for JADC2 and the JADC2 line of effort that integrates with, in our case, the NC3 enterprise, if that's being helpful, because we're trying desperately to influence things so that it's not an Air Force system, it's not a Navy system. They can talk amongst each other. Marine Corps sensors. That's what I'm trying to see if that messaging is getting put into ICDs so that when it goes to industry and they're seeing things for new systems or development that are things that are in the operational baselines that are actually that's being taken into account. Are you actually seeing the kind of unified messaging?
Yeah, I think the discussions are taking place and we're starting to have the right conversations. It's tough to, it's a Navy program here. It's tough to turn an aircraft carrier, and I think we're seeing, it's slow to emerge. If you look at all the software factories that have popped up in the last 5 years and working through that, we went through a period of experimentation to implementation to now we're seeing some real traction. Those are, I would suggest, inside of each of the services rather than cross-service type of activities. We're starting to see legislation that allows for multi-year programming of software activities outside of the classic hardware development. But I'll go point to the FAR and 5000 and all of that. We still have a lot of waterfall mandates that we get bogged down in terms of we're working through it. So I would say from an industry standpoint, we're hopeful. I'll come back to, at CACI, we've kind of taken a really aggressive stance of not stamping stuff intellectual property and working through it. Software really is a value creation every day. What I do today is going to be dramatically different than what I do tomorrow, and if I can get it done and work through it. And these guys, coming together and collaborating in that agnostic space has been a fantastic journey for us, not just on Spectral, but many of the other things that we're doing out there. So I appreciate the question, and I appreciate you letting us rib you a little bit on the grades. I don't think Nate gave you a B, though. I'm gonna leave it. I'm gonna leave it at that.
I give Navy a higher grade than other services.
Fair enough. Yeah, there you go. All right, we got time for a couple more questions. Sir.
Good afternoon, Shannon's Oak Surf Pack. Just had a question. Every day I'm seeing our sailors trying to maintain the systems in the fleet, so self-sustainability is very near and dear to my heart because we're trying to keep the systems up and we don't always have connectivity to connect back and get direct support. So what are you guys doing to make the systems be so they're the architecture and both the parts that are used on them and the training for the sailors is going to keep up and make our sailors be able to keep their systems up without having the support and the tether back to an ISEA to keep their system running?
Yeah, no, that's That's a great question. I'm going to push this over to you, Christian, because I know once upon a time I worked with one of those acquisitions where we partnered with the Air Force to kind of build combat programmers, really where we had airmen trained from a software standpoint. And when you have the continuous ATO, you're not going to want them to do major surgery, but doing patches or changing the look and feel of something or reacting real time while you're in that real world, I think is a doable thing. So.
Well, I guess it all comes down to design, right? I mean, high availability. I mean, the systems that are fielded by the program that whatever's on your ship, needs to be high availability from both a software perspective and a hardware perspective. And what we were talking about earlier is zero touch deployments with Kubernetes on bare metal, where it's been pre-tested, pre-engineered. Basically, you just like Nate was saying earlier, just push one button and it gets deployed. It automatically boots up, so you could have spares on board. You could, just rip it out and plug in another one. Plug and play. A lot of the Dell servers are all plug and play. So if a drive goes down or a network card goes down, you can pull it out. So you maybe have onboard spares. And there's also virtual maintenance, AR, VR type maintenance, where you could just put on a pair of goggles and actually see what you're doing, and it's almost like self-training. So there's lots of things that we could be doing. It just needs to go through the procurement process and get built into a program. But I would go with high availability on both hardware and software. Number one, automate through orchestration. Number two, and maybe get the onboard spares for number three.
Yeah, so I just add one thing to that, and you hit on it though. With the orchestration, right, you're not going to have as much maintenance because the system's going to detect when things aren't operating correctly and then heal itself, right? So your sailor's not going to need the assistance manual that tells you how to go through and figure out, okay, I need to give the computer this command in order to restart this process. That's what they do today because that's how it's built. But when we get to a microservice containerized solution that's orchestrated, then what you won't even know it's happening, and it just restarts itself and it just starts working again. And so that's really how you get to that point, right? Is eliminate the need to have to do as much maintenance. And when you do have to do something significant, then the things Christian was talking about are the way to go.
Any other questions from the audience? Please.
So having been in industry for a long time, and I'm on the vendor side, can you hear me? So I'm with GitLab today, but the elephant in the room has always been edge, and the edge, to Dan's point, has always been that physical limitation. We can talk about the hardware, the software all day long. We can build systems, but when you get out in theater, air, land, space, everything goes awry. I think that there needs to be better collaboration. When we talk about hardware solutions, software solutions, there needs to be better integration with government and industry, to Christian's point, to bring this to a close. I mean, this has been 20, 30 years we've been battling this same thing. We need suitcase-sized, we need ship-sized, we need plane-sized solutions that are plug and play, that our folks and our soldiers don't have to go fix, repair, learn. So I just think there needs to be better collaboration. I think we're not trying to sell anything at this point. I think we're trying to solve a problem. So just my 2 cents.
No, that's fair. Anybody want to?
100% agree.
Yeah. Anybody want to jump in on it though?
Yeah, so I think one of the interesting challenges with the tactical edge is that we're never going to get the bandwidth to do what we want to on the edge, right? The second we improve the bandwidth and the second they replace all of those things with the next best thing, the software and the need is going to go that much higher, right? So it's never going to be like equals where we're always going to get everything we need at the edge. What we have to do is we have to figure out how to use the bandwidth that we have most efficiently, right? And so we've actually been doing that a long time in terms of streaming like large quantities of data from the ship back to the shore. And one of the tricks to that is kind of the special sauce of what our group in Austin does. And we're actually building the next generation of that, hopefully here very soon, as the Navy employs us to bring a technology called JET to the forefront of this interoperability solution that I talked about. And what we're doing is we're breaking all of the, like, if we had to start over and figure out how to do that that transport across the tactical network that's latent and it has lots of problems, how do you figure that out, right? And so we're going back and getting rid of all of the old technology and going with some newer things that Google and a few other folks are doing today that is going to rapidly increase the amount of data I can get across a low latent bandwidth.
Yeah, and I'd still go back to the recent silicon advances again. I was taken back the other day by even a relatively low-power microcontroller company now is including AI edge processing. In other words, neural net, inference capabilities within their microcontrollers. So the advantages that we're going to see there, are really, going to give us another bump at the edge. But I think there's consensus that there's never enough network bandwidth. There's never enough processing horsepower. So yeah, we just got to do the best we can with what we have.
Yeah, and I think, Nate, to your point, and this one was key to me, we can't continue to look at dead software that sits for 10 years without updates.
Yep.
And that is, I think that's going to be key to us becoming a superpower, right? Continuing to be a superpower is that we can't wait 10 years to upgrade shipboard software. We can't wait 10 years to upgrade space software. So that to me, and we have lived under that rule for, we won't say how many
gotta get
years,
faster.
but it's got to get
Yeah,
faster than
it's got
10
to.
years. So thanks, guys. Appreciate it.
Good. I think we're coming to an end, but that's actually an interesting point to wrap up, and because I think it talks to, I'll say, the challenge that the military has writ large, right? So it's one thing to go build an application for your cell phone, and maybe it's a mapping application, and it really gets crowd tested. And if grandma doesn't get to her hair appointment on time because the mapping application had her move somewhere off of that, it's fine if you field something at 85%. But the military is dealing with high consequence, no fail type of operations. You can't put that in an F-18 and have an F-18 software work 85% of the time. High consequence means you have to be more deliberate about testing. You have to be more thoughtful about an architecture. You have to build architectures, though, because modern capabilities really mandate that, with the ability to adapt, building it in from the ground up. And I think that's what we're seeing. This team's certainly done that. Josh mentioned that there's cross-pollination across any number of programs with various capabilities that we're working on. And then I'll close with two, and we talked a little bit about it. The Navy's got a further complication that maybe the Air Force or the Army doesn't have to worry about. It's that degraded environment and the fact that it's a non-tethered environment and they have to go work through it. I will say, though, I think the future is bright, and teams like this that are coming in with an agnostic approach, a collaborative mindset, and leaning in to partner with our government customers. I've been really excited with what I've seen over the past couple of years, and I'm really excited about this team. So I appreciate y'all listening, appreciate you being here. Fantastic questions. Alan snuck out. I was gonna talk more about him because Nate gave him a bad grade, and we need to pick him back up on that. But there you go. Thanks for being here, and looking forward to seeing you throughout the conference. We'll be up here to answer some questions. Thanks.